We are going to look at geometry sequences in this video. Suppose you start with a piece of rock 1 meter long. You cut half on the first day, then cut half of the remaining the second day, and so on. How much you have cut in 100 days? So first day you cut half, second day you cut half of half, which is 1/2 square. Third day you cut another half of half square, which is 1/2 power 3. In this way, after 100 days, you have cut half times half plus half squared, half cubed, all the way until 1/2 power 100. Next, we look at another example. Consider this 8x8 chessboard. Suppose you put 1 grain of rice in the first square. So first square you put 1. Second square you put 2. Third square you put 2 square, which is 4 rice. So how much rice need to fill up the chessboard? First square is 1. Second square is 2 grain of rice. Third box is 2 square grain of rice, and so on. So you'll find that by the time you reach the last square, it will be 2/63. There is actually a similarity between the two sum you're looking at. You'll notice that from half to get half, 1/2 squared, you multiply by half. Then from 1/2 squared to 1/2 cubed, you multiply by another half. So you'll find that here you keep multiplying by half to get the next term to be sum. Same thing here in the chessboard example. You multiply by 2 each time to get the next number to be added. In general, if you start with a number A and keep multiplying by R to get the next term, so with A, AR, AR square, AR cubed, and so on, you get a geometric sequence. And the number R is known as common ratio. And because you keep multiplying by R to get the next term, if you start with a geometric sequence and you look at 2 consecutive terms like A2/A1 or A3/A2 and so on, right? You should get R as the answer if you divide the two numbers, the 2 consecutive terms. So R is given by the ratio of any 2 consecutive terms. And if you start with first term A, you multiply by R. You multiply by R to get the next term AR, then AR square, AR cubed, and so on. To see that the general term is AN is A times R power n minus 1, you just need to take note that when it's A5 is power 4, R power 4. When it's A4 is R power 3. So the power of R is always 1 less than the index you're looking at. So that's why AN is ARn minus 1. And we always assume A is not 0, because if you start with first term 0, then every term of the sequence will be 0. Let's look at an example. If you start with a geometric sequence in this example, and you are given that the first term exceeds the third term by 112, the second term exceeds the fourth term by 84. So we're supposed to find the first term and the common ratio. The first term you denote by A, then the common ratio you denote by R. And you are supposed to find the number of terms which exceed 50. recall that a n is a r n minus 1. So a1 is just a. a2, you just sub n as 2. You'll find a2 is ar. Then a3 is ar squared. a4 is ar cubed. So from the first information, the first term exit means bigger than. So if you minus the third term, which is ar squared, it should give you 112. Okay, and you can actually factorize out a 1 minus r squared is 112. So let's call this equation 1. Then you are given the second term. The second term is ar, right? Then minus the fourth term is ar cubed. It gives you 84. And you can take out ar as a common factor. Then it gives you 1 minus r squared, 84. So we can call this equation 2. And then you notice that you can just substitute. You can actually make a substitution. Okay. So you'll find that a and 1 minus r squared is same as the left hand side of equation 1. A 1 minus r squared. So it can be replaced by 112. So that's why it becomes 112 r is 84 if you make a substitution. So with that, you get r is 3/4. And then you can substitute inside equation 1. Then you can substitute into equation 1. Then you will get a1 minus 3/4 square is 112. So from here you can work out a will be 256. So we have found a and r. Then you're supposed to find number of terms exceed 50. So you want a n more than 50. So you want a r n minus 1 more than 50. A you just found is 256. R is 3/4. N minus 1 more than 50. So with that, you need 3/4 n minus 1 more than 50 over 256. And then you can take log on both sides. So you take log on both sides, so it's log of 3/4 n minus 1 more than log of 50 over 256. Okay. So we have log of 3/4 power n minus 1 more than log of 50 over 256. And then you can bring down log. Remember, log x power n is n log x. Let me erase this. You can bring down the power. So it's n log x. So that means you can say n minus 1 Lg 3/4 more than Lg of 50 over 256. So after that, we can divide by log of 3/4, n minus 1, and then you have to be careful at this step. Okay, careful at this step. So divide by log of 3/4. So it means on the right hand side it should be log of 50 over 256 divided by log of 3/4. Okay, and you have to be careful of the inequality sign. Remember, if you divide by a negative number, right? Okay, so before that, let me talk about this. If you consider a number x less between 0 and 1, then you find the log x is actually less than 0. It's actually negative. So if you divide by a negative number, right? You know in inequality you have to reverse the sign. So here should be less than. Here should be less than. Okay. So you take note. It's less than because you divide by log of 3/4, which is a number less than 1. 3/4 is a number less than 1. So log of 3/4 is a negative number. So if you divide by a negative number, you must reverse the inequality sign. So with that, n is less than log of 50. Log of 50. Log of 50 so it's log of 50 over 256 and divided by log of 3/4 and plus 1. So you'll find that this will give you about 6.7. So n has to be less than 6.7. So that means n will be 6. So that means the number of terms at 650 will be A1, A2 until A6. So that means the answer here, the number of terms right, is at 650 should be 6. There are 6 terms, A1 to A6.